we are going to spend lesson 6.4 and actually 6.5 learning about something called polar coordinates. Okay, you kind of see a glimpse down there at the bottom of the page that we're going to be looking at that circular graph in order to graph our polar coordinates. So we traditionally graph with rectangular coordinates. When I talk about an ordered pair in rectangular coordinates, what's an ordered pair in regular coordinates? It's x comma y, right? So rectangular coordinates are traditionally x comma y. That's what you've grown up using, knowing. We're going to spend this lesson looking at the connection between how rectangular coordinates and polar coordinates relate. Polar coordinates are of the form r comma theta. R standing for the radius, and theta, of course, standing for the angle. Okay, so that's the form we're going to look at. Now, here in a moment, I'm going to talk about 4 connections or relationships, and those relationships will connect rectangular coordinates and polar coordinates. But before I do that, I kind of want to look at a graph here. So if we talk about a point, then I'm going to call point P. Okay? Now, the idea that P in rectangular coordinates, how do you get to P in terms of rectangular coordinates? You do what? You go over X, and then you go up Y, correct? You've seen this triangle before. So with rectangular coordinates, you go over X, up Y. It does create a right angle, but that would be point P in rectangular coordinates would be x comma y. Of course, we know the horizontal axis in rectangular coordinates is my x-axis. The vertical axis is my y-axis. What about that center? 0, 0, also known as the origin. Okay. I just have 0, 0 written on my paper, but, you know, I want to review the vocabulary of origin as well. Okay. Now, making sure I think I have everything there. That is all of your basic already knowledge you have, yes? Now we're going to talk about polar coordinates. When we start talking about polar coordinates, instead of this being the x-axis, we're now going to call this the polar axis. Okay. The y-axis won't really exist because we're working on something that looks more like the unit circle than it does, you know, the rectangular. So the unit circle doesn't really, or excuse me, the y-axis doesn't really exist. Instead of this centerpiece being called the origin, this is called the pole. Also, whoops, referred to as point O. Okay. The angle at the origin, of course, this angle right here, formed between the line that goes up to the point and the polar axis, is your theta. What am I going to call the hypotenuse of that triangle? This is your radius. Okay. And a point P in this scenario is r comma theta. Okay, so it can be this, it's the same point in the same location. It just depends on what type of information we're using. Are we using our traditional XY coordinates and all of that, or are we using polar coordinates? Now, some connections that can be made. If we talk about theta here, okay, first one I'm going to use, and I'll explain this here in a moment, x is equal to r times cosine theta. Now, that shouldn't be too much of a surprise because what do you know about the first coordinate in an ordered pair on the unit circle? It's the cosine value, right? X is the first number in a unit circle or in a regular ordered pair. You can also think this way, guys. Theta. What's cosine? Cosine is adjacent over hypotenuse. So the cosine of theta is technically equal to x over r. But if you take the r and multiply it over, it's x is equal to r cosine theta. Take a guess. What am I going to say about y? Y is equal to r times sine of theta. Okay, and that would be the same thing. If you look at theta, sine is opposite over hypotenuse. So sine would be equal to y over r. And if it's y divided by r, you can multiply that r over, so y equals r sine theta. We can also talk about tangent. This one I don't have multiplied out, but tangent of theta is equal to what? Opposite over adjacent, or y over x. And finally, the fourth part is looking at the triangle in general. You guys can finish my sentence. X squared plus y squared is equal to r squared. Okay. This is information where if you know your polar coordinate, if you know r and theta, you can use the top two to find x and y. Or on the flip side, if you know your rectangular coordinate, you know x and y, you can use x and y to find r and theta. Okay, so that's how we'll use those conversions. We'll use them more when we get to the backside, whether that be the end of class today or the beginning of class tomorrow. Probably towards the end of class today. Okay, got what you need on that page? We're going to go down and do some graphing. Okay, we've got to learn how to graph. Just basic points. Okay, it's basic points. It's, I don't know, kind of funnish. Now, with this, okay, so polar coordinate plane looks a lot like a unit circle, yes? Okay, looks a lot like your unit circle. Unit circle, we just don't always necessarily have to have the rings on it. Okay, the dark line, which isn't really on there, to be honest. The dark line I'm talking about is this right here. What did I call that dark line up top? That is your polar axis. It is also, I knew I had something else written here, your ray going from the center. So your ray from that center point, which I'm going to call the O there. What's the center called? The pole. Vocabulary mentioned up top, but just trying to make sure we have it. Okay, and that is that center point. Okay, now, when we plot points on this polar coordinate grid, okay, this is what we have. First of all, you have to work a little backwards here, because you'll notice it asks us, normally on rectangular coordinates, we do x, comma, y. Here, we're going to do theta, comma, r. So we're going to do, instead of the first coordinate, second coordinate, you do the second coordinate, then the first coordinate. Now, before we start graphing these, your unit circle is missing something, isn't it? Or not unit circle, your polar coordinate grid is missing something. Are we missing some measurements? Let's go put some measurements on. I'm going to help you think about this because here's the deal, guys. Those of you continuing on into math, whether it be here at TC, whether it be in college, you continue on into any type of calculus or anything that uses trig, they're not going to necessarily provide you the unit circle, are they? They're going to expect you to know a lot about this without having it right in front of you. So, if we label this, we of course know that that is 0. What about our other big ones? Up top is 90, or I'm going to be annoying and go in radians, pi over 2. To the left is pi. Down low is 3 pi over 2. Hate to be the bearer of bad news, but yes, polar coordinates are traditionally written in radians, so I'm going to label this in radians. Now, this one is similar to my grid on the sideboard where it has the extra lines in it, right? We worry about the middle 3 lines when we're labeling, and we worry about those middle 3 lines. What are my middle 3 lines in that first quadrant? Pi over 6, pi over 4, and pi over 3. I would hope I've at least gotten you that far this year. Can we at least put those down, right? Okay. The other two are, if we're breaking this into 12s, just ignore them for right now. We don't need them. Now, here's the trick. Can you fill in the other 3 quadrants without just looking at something? Okay. And I know the answer for me, even for a long time, was no, I can't. So keep in mind, my denominators were 6, 4, and 3. Guess what we have in every quadrant, right? Same denominators. Now, here's what I reference in the second quadrant. All of my answers in the second quadrant are right before pi. So, for instance, pi over 6 is the first one we label up from the x-axis, right? So over here, the equivalent angle is right here. That's my pi over 6 angle. What pi over 6 angle is the first one before pi? As in, if pi is 6/6, what comes right before 6/6? 5/6. Am I making sense at all? So that one is 5 pi over 6. Those are the 6 are always closest to the x-axis. In the middle of every quadrant is always your denominator of 4. What fourth is going to become right before pi? 3/4, right? If pi is 4/4, what's going to become before that? 3/4. The one up top is your thirds. That's the one farthest from the x-axis, right? What's the thirds going to be before pi? So what's right before 3/3? 2/3. Did I make a little bit of sense there? Okay. In my second quadrant, I'm looking for all the angles that are right past pi. Okay. So now, I'm skipping a line. Closest one to the x-axis is your denominator of 6. What denominator of 6 is right past pi? 7 pi over 6, because we're just going right past 6/6. Okay, my middle line is a denominator of 4. What's right past pi when we're talking fourths? 5/4, because you're right past 4/4. And here we're talking in terms of thirds. What do we have down here? This is 3/3 and this is 4/3. And one more quadrant. This quadrant is whatever's right before 0, but this is also 2 pi. So think in terms of 2 pi. Which way do you want me to start? If I start here with the thirds, what's going to be right before 2 pi?
7.
No. 2 pi in terms of thirds is going to be 6/3. So what's right before that? 5/3. So this is 5 pi over 3. In terms of the fourths, this is going to be right before 2 pi, so right before 8/4, which is 7/4. And 6th. Yeah, because right before 12/6 is 11/6. I don't know, maybe there's other little shortcuts and, ways to label that, but the more you work with it, the more you know. At this point, what I'm hoping is helps, can you at least figure out which quadrant everything is in? I always think, is it right before pi, right after pi, or right before 2 pi? That's kind of my reference. Okay, shall we graph? Okay, guys, remember, it's first plot theta, then the r. So in point A, the ordered pair is 3, 2 pi over 3. So first of all, we need to find the theta. Where is 2 pi over 3? Okay, it is this line or ray in quadrant 2, yes? Now, what's my r value? I have an r value of 3. What do you think we're going to do on that line of 2 pi over 3? We're going to count out 3 radiuses, or in other words, 3 rings. So each ring represents a unit of 1. So you're counting out to the third ring on the 2 pi over 3 angle, and that is point A. Not too bad, right? Find the angle, count out how many rings. Okay, ready to try B? We've got to throw some negatives in here, right? 4, negative 3 pi over 4. So first of all, think about how do you graph negative 3 pi over 4. I always try and give you the out with the negatives, but we've also got to learn them. So what do we know? 3 pi over 4 goes over to quadrant 2. What's negative 3 pi over 4 do? It goes to quadrant 3. Because remember, 3 pi, a positive goes counterclockwise. A negative angle goes backwards. It goes clockwise. And so you are going to 5 pi over 4. So the idea is that negative 3 pi over 4 is the same angle as 5 pi over 4. So now I'm on the 5 pi over 4 line, and my r value is 4. So we count out 4. And that's my B value. Now, I don't know why I didn't put C first, but C should have been the first one you did, really, but that's all right. 1 pi over 4, can you handle that? No tricks here. Go to pi over 4 and go out 1. That's point A. Okay. Ready for D?
Wouldn't that be point C?
I guess I just wanted multiple A's. That would definitely be point C. I don't know what I'm thinking there, but thank you. Okay, point D. Negative 2, 7 pi over 6. So where is 7 pi over 6? It's here in quadrant 3. Guesses on an R value of negative 2? Going what? The opposite way. So 7 pi over 6 tells me what angle I'm at. A positive 2 would go out on 7 pi over 6. A negative 2 is going to go backwards through the pole. Okay, kind of like you're used to what? Positive values take you right, negative values take you backwards. They take you left. So 7 pi over 6, if we have a negative R value then, which line are we going to end up on? You're going to end up on pi over 6. And you're going to go negative 2, so you end up 2 out on pi over 6. Okay, so a negative R value, I always say it shoots you backwards through the pole. And you end up on the other side of the graph. Just follow the diagonal. Are we okay with that one? Now, all of that to say, and we'll talk about this on the back page, that what is another name for point D? Another name for point D is the fact that it was 2, pi over 6. That's where we actually graphed it. Like everything on the unit circle, there's multiple names for every point. Okay? And E. We're going to throw both negatives in at once. Okay, so where's negative pi over 3 going to take me? Okay, we're going to end up at 5 pi over 3. Then, where does negative 1 take me? through to the other side, so shoot you backwards to the pole. And so then we're going to end up at 1 on 2 pi over 3. And that is point E. So find your angle, and then count your rings. Kind of fun, right? We've done a lot worse. I look at it that way. Okay, questions on that part? If you're not going to be here tomorrow, see me before you leave. I have a copy of a graph like this, so you don't have to try and draw this graph in homework. Because in homework, you have like what we did here, where you have a handful of just points to graph. So I'm going to give you a half sheet that has a graph like this on it, so you can have a graph form. Okay? So, now, on the back side, we're not going to get too far in this, but I just want to kind of give you an idea of what we're going to be looking at tomorrow. Okay? We're going to be working on going back and forth between polar coordinates and rectangular coordinates and vice versa. Now, keeping in mind, I'm just going to share a little bit here. What do we learn on the front side? What do we know about a polar coordinate? A polar coordinate is what form? R comma theta. A rectangular coordinate is what form? X and Y. So the idea here is we're going to be going back and forth between those. Now, I'm just going to write them up here so we have them. We learned 4 conversions on the front side, yes? Let's write them down so we have them on the back side. We have that X is equal to R cosine theta. Y is equal to R times sine of theta. Tangent of theta is equal to Y over X and X squared plus Y squared is equal to R squared. Right? Now, okay, real quick, we won't get far, but this is kind of what I did in my morning class too. A, what's it say? It says the polar coordinates of a point are given. What's that mean 5 and pi over 6 are? R and theta. What do they ask me to find? They're asking you to find the rectangular coordinates, which are X and Y. We know R and theta. How can we find X? X equals R cosine theta. It's essentially a plug and chug, guys. It really is. So we're going to use the idea that X is R cosine theta. So X is going to be 5 times cosine of pi over 6. Don't necessarily reach for the calculator. What is cosine of pi over 6? Unit circle, reference chart. Cosine of pi over 6 is? Square root of 3 over 2. Yes, straight from the chart. I'm not doing anything fancy. So 5 times square root of 3 over 2. I personally would say this is 5 square root of 3 over 2. I'll have to check tomorrow and see what the answer key is in, because I do also have written in my notes that it's 4.33. And tomorrow we'll find the other half of our rectangular coordinate, which you probably can already figure out how to do. Okay? So we'll practice with this some more tomorrow. I would like to think we'll be able to have some work time. Okay?